Good morning, Unites. Today is Sunday, the 10th of May. We're now in week 6 of the online learning, and today is lesson 1 of 4. So we're now going to move on to solving linear inequalities. So just to recap, so inequalities are solved in the same way as algebraic expressions, equations, except that when multiplying or dividing by a negative number, the inequality sign is reversed. Now we'll see what this means in a little while when we have a look at some examples. Okay, but the steps are basically the same. So in generally, when we have an equation, we have the left and the right side of the equation, okay, and we need to treat both sides the same as we would do in solving a linear equation, but it's shown as an inequality. Now, before we move on to that, I just want to have a quick recap of the lesson we did on Thursday, which was lesson 4 of 4, when we had an introduction to inequalities. So if you just bear with me once again, I'll bring up the PowerPoint. So if you remember, I gave you this last set of questions to do as homework for the lesson 4. So the question was state the inequality displayed on each number line before. So here you got from 0 to 5. So this was n is less than or equal to 5 and greater than or equal to 4. This one was, again here, look, this is not included. So this is n is less than or equal to 4, but greater than -5. The third one, again, look if it's solid or not. So n is less than 5 and greater than 0. And the last one, n is less than -3, but greater than or equal to -5. Okay. So moving on, solving linear inequalities. Now we're going to have a bit of a recap first of inequalities, and then we'll have a look at how to solve them. Okay, so as we know, an inequality is an algebraic statement involving symbols less than, greater than, less than, equal to, or less than or equal to. Okay, so as we know, x, this means x is greater than 3, this means x is less than -6, this means x is greater than or equal to -2, and this means x is less than or equal to 10. And sometimes two inequalities can be combined in a single statement. For example, if x is greater than 3 and x is less than or equal to 14, then we can write this as x is less than or equal to 14, greater than 3. Inequalities can either be read from left to right or from right to left. So for example, this one can be read as 5 is greater than -3 by reading from left to right. It can also be read as -3 is less than 5 by reading from right to left. So in general, x is greater than y is equivalent to y is less than x. And x greater than or equal to y is also equivalent to y is less than or equal to x. Now, representing inequalities on a number line, so suppose x is greater than 2, so there are infinite many values that x could have. Okay, so x could be equal to all these values as they're all greater than 2. As it's impossible to write every solution down, we can therefore represent the solution set on a number line as follows. Yeah. The hollow circle at 2 means that this number is not included, and the arrow at the end of the line means that the solution set extends in the direction shown. Suppose x is less than or equal to 3. Again, there are infinite many values that x could have. We can represent the solution set on a number line as follows. The solid circle, as I said last week, at 3 means that this number line is included, and the arrow at the end of the line means that the solution set extends in the direction shown. Now, suppose x is less than 4, but x is less than or equal to -1. So here, although x is between two values, there are still infinite many values x could have. Okay. So like I said, you've got to show the possible solutions. So showing this on a number line, we will show it like this. So anything in between these two is a solution to this inequality. So solid circle is used at -1 because the value is included, and the hollow circle is used at 4 because this value is not included. And the line represents all the values in between. Now, in the examples we've looked at so far, we have assumed that the value of x can be any real number. Sometimes we're told x can only be an integer, that is a positive or negative whole number. So, for example, here, lists the integer values that satisfy this inequality. So x is less than or equal to 5, but greater than -3. So all these possible values satisfy this inequality. Satisfy means basically, if this is a problem, what's the solution? Okay, but this term is used in mathematics to say that it satisfies this problem. And write down inequality values obeyed by the following set of integers. So there are 4 possible inequalities to give this solution set. So here we say x is less than 2 but greater than -5. X is less than 2 but greater than or equal to -4. X is less than or equal to -1 but greater than -5. And x is less than or equal to 1 but greater than or equal to -4. So all these 4 are possible solutions to this set of integers. Remember that when we use a less than or greater sign, the values at either end are not included in the solution set. Now, moving on to today's lesson, so we said solving linear inequalities. So look at the following inequalities. So x plus 3 greater than or equal to 7. So we're saying what solution for x would keep this, statement satisfied. So what values of x would make this inequality true? Any value of x greater than or equal to 4 will solve this inequality. So we could have solved this inequality as follows. So here we're saying x plus 3, so value plus 3 is greater or equal to 7. So what value, we're saying 4 would solve this. So we're saying 4 plus 3 is 7. So 7 is greater or equal to 7. Now, as we said at the beginning, we're going to use the same rules we solve, use them solving linear equations. So treat both sides the same. So if I subtract 3 from both sides, so that will be x plus 3 minus 3 is greater than or equal to 7 minus 3. So these two 3's cancel each other out to give you x is greater than or equal to 4. 7 minus 3 is 4. The solution has one letter on one side of inequality and an inequality sign and a number on the other. Okay, so like an equation, we can solve an inequality by adding or subtracting the same value to both sides of the inequality sign. We can also multiply or divide both sides of the equality by a positive value. So for example, here we say 4x minus 7 is greater than 11 minus 2x. So if I add, I want to get rid of this negative 7 because I want with 4x by itself. So if I add 7 to both sides, that's going to now give me 4x is greater than 11 plus 7 is 18 minus 2x. Now I get rid of this negative 2x by adding 2x to both sides. That gives me 6x is greater than 18. So we want 1x, so divide both sides by 6. That would give me x is greater than 3. So the solution for x is any value that's greater than 3. So how could we check the solution? By again substituting. So to verify that x is greater than 3 is the solution to 4x minus 7 is greater than 11 minus 2x. We substitute value just above 3 into the equality and then substitute value just below. To substitute x is 4 into inequality, we have this. So 4 times 4 is 16. 16 minus 7 there will be 9. 11 minus 8 to give us 3. So 9 is greater than 3. Is that true? Yes. So if you substitute 2 into inequality, we have this set of solutions. Is 1 greater than 7? This is not true. Now, the tricky part with solving inequalities, well, it's not really tricky, but the thing you've got to try and remember is that when you multiply and divide by negatives, that the inequality sign is reversed. So although most inequalities can be solved by equations, we have to take great care when multiplying and dividing both sides of inequality by negative value. So the following inequality is true. 5 is greater than minus 3. Look what would happen if we multiply both sides by negative 1. So minus 3 times minus 1 will give you a positive 3. And 5 times the minus 1 will give you a minus 5. So obviously we can't say minus 5 is greater than a positive 3. So to keep the inequality true, we have to reverse the inequality sign. So this less than sign changes and becomes a greater sign. Okay, so when you're multiplying or dividing by negatives, you have to, at the final stage, flip the inequality sign to make the inequality statement true. So remember, when both sides of the inequality are multiplied or divided by negative, the inequality is reversed. So for example, we have 4 minus 3x is less than or equal to 10. Subtract 4 from both sides, gives us minus 3x is less than or equal to 6. We want to get the x by itself, so divide both sides by minus 3 with coefficient. That gives us x is greater than or equal to minus 2. So remember how this inequality sign, that because we divided by minus 3, we've got to reverse it to make it greater than or equal to. So we could also solve this type of inequality by collecting x terms on the right and reverse the inequality sign at the end. So if we do this again, but using a slightly different method, add 3x to both sides, subtract 10 from both sides, divide both sides by 3 to give us again the same solution. Now, if we have combined, so that means, brought together, so the two inequalities, 4x plus 3 is greater than or equal to 5, and 4x plus 3 is less than 15, can be written as a single combined inequality, like so. We can solve this inequality as follows. So subtract 3 from each part, divide each part by 4, 2 divided by 4 is 0.5, 4x divided by 4 is x, 12 divided by 4 is 3. And we can illustrate the solution on the number line. Okay. Now, I'm not going to go into too much in depth to this. We need to obviously keep to the examples and the level of difficulty of the question, start within the book. And as we progress, we can, at a later stage, bring in these multiple steps to solve these inequalities. Okay? So you won't be doing this right now, but I'll just finish off examples with you. So we can write the complete solution as x is greater than or equal to minus 2, but less than or equal to 5, and illustrate the number line as so. Okay, so moving back now to the so you've got the example 17. So it shows you, for example, solve inequality x is greater than 4 but less than or equal to 10 and show result on the number line. So here it shows you split the inequality into two parts. So we've got x is less than 10 and x is greater than 4. So you can show all the possible solutions to this inequality on this number line. Then you've got example 18. So you've got solving inequality here and show result. So if I got 4 is greater than 13 minus 3x, so add 3x to both sides, that gives me 3x plus 4 is greater than or equal to 13, so subtract 4 from both sides, give me 3x is greater than or equal to 9, divide both sides by 3 to give me x is greater than 3. Again, you can show then this solution on a number line. Then you've got example 19 from the book again. So it's got all the steps here. And then you got example 20 showing the inequality here. Okay, so these will, you'll need this for the questions later on, but to begin with, we look at easy questions first. So as I said, x, so the key point is x is greater than 4, means that x can be equal to 4. X is greater than or equal to 4 means that x can be equal to 4 or greater than 4. And finally, the solution set of inequality collect up algebraic term on one side, and when multiplying and dividing by a negative number, reverse the inequality sign. So for today, we're going to do the questions from exercise 6. So insert the correct symbol less than, or greater than, or equals to into these expressions. So we've got question 1, 2, 3, 4. So minus 3, is it less than or greater than 3, or is it equal to 3? 30%, is it greater than or less than or equal to 1/3? Minus 3, is it greater than, less than, or equal to minus 4? 0.3, is it greater than, less than, or equal to 1/3? Question 5, write down inequalities represented by this number line. Okay. Question 6, write down the inequality, the single inequality represented by this number line. And that's it for today. So you've got these 6 questions. Remember to copy them down, show your workings for these questions. You have to put the inequality signs in here. This is at a grade 5, so these should be fairly straightforward. And then in tomorrow's lesson, we're going to do some more solving linear inequalities. So you might have to refer to the PowerPoint again from today's lesson. Or if you need me to, I can put the PowerPoint up again in Monday's lesson, so you can refer to it if you need to. But you've got the examples in the book, so you're just going to be doing these questions in tomorrow's lesson, and there's a few more. But for today, we're just doing 6 questions. Okay? Any issues, let me know. Just try your best as always. And if you're ever in doubt, always check with the solutions at the back of the book to make sure you're on the right page. Okay, guys? Anyway, enjoy your day, and I'll catch up with you guys on Monday. Thank you.